so this is now the second part of, or second way of solving systems of equations. The first part was graphing. The second one will be substitution. Substitution method is used to eliminate one of the variables by replacement when solving a system of equations. Okay, so it's like grabbing one variable equals from one equation and then plugging it into the other equations. It's very important to use the other equation from the variable that we grabbed from the first equation. Okay, so I have here some steps, okay, that we can follow so that we can solve linear system using substitution. There will be two ways here. Either you want to solve for y from the first equation, or you want to solve for x from the first equation. Either way, you're going to get the same answer. So let's try to illustrate the following steps. So let's say this is my example number 1. And for this example, we are going to solve for y. Okay? But remember, you can also solve for x. Either you solve for y or solve for x. Okay, doesn't really matter. Okay, in this case, I'm going to demonstrate to you guys on how to solve for y. Now, if you look at example number 1, both equations were already solved for y. So we don't need to do number 1, okay, because number 1 is done already. Okay, so done. All right, next, I'm going to get the y value and plug it into the other equation. So in this case, I'm going to get this value for y, and I will replace the value of y to my second equation. Okay, so here's what's going to happen. I'll take this and plug into my y here. So I will have here x plus 3, but the y is equal to negative 2x. All right, now let's solve this equation for x. So first, how do we solve for x here? We subtract x on both sides. So we'll be able to get 3 here, negative 3x. And then we divide both sides by negative 3. So x here is equal to negative 1. Okay? Now, once you have a value for x, place this new x value into either of the original equations in order to solve for y. Now, you have the option of choosing the first equation or choosing the second equation. I would just use my first equation. Okay, so using the first equation, I will have y is equal to negative 2x, but x is equal to negative 1. So I will have here negative 2 times negative 1 will give us a positive 2. So I have the x value and I have the y value. So in this case, I will have now my x is equal to negative 1, and then my y is equal to 2. So this will be our solution. If you remember, this equation was a same equation. This system of equations was the only is also the same system that we used yesterday. Okay, but instead of using substitution, we use graphing. Okay, and we got the same result, negative 1 comma 2. Now, of course, we need to check our answer. We need to verify our answer by plugging back in this point to both of our equations. So to verify, I'll just use this space here. So I'll use my first equation, y equals negative 2x. Replace my y by 2. We are now verifying. My x is negative 1, Note that negative 2 is equal to the right side, which is equal to 2 also. Sorry, positive 2 is equal to 2. So it worked for the first equation. For the second equation, y equals x plus 3. Replace your y by 2. Replace your y by 2, x by negative 1, and then check if it's going to work. We have 2 equals 2. So indeed, negative 1 comma 2 is a solution. Okay? So for this system, the solution will be negative 1 comma. Alright, so let's have example number 2. In this case, let us solve for y. Okay? You have to choose one equation here and decide which equation you want to solve for y. You can solve y in the first equation, or you can solve y you can solve y from the first equation, or you can solve y from the second equation. Okay, and I believe the second one is better for us to solve y, because if you solve y here, what's going to happen? You will have a fraction. Very good. And you will have a fraction. So I will just solve y here. Okay. So I'll solve y here. So your y here will be equal to what? Negative 3x plus 7. So I'm going to use this y value and plug into my first equation. Okay. So I have here x plus 2y equals 4. But the y that we solved from the second equation is equal to negative 3x plus 7. So again, I took the y value from my second equation and plug it into the first equation. After doing the second step, we are going to solve now, in this case, x. Okay? So when you simplify this, you're going to get an x value. So we will have x, distribute the 2, I'll get negative 6x. Then 2 times 7 will give us 14 equals 4. Then 6 minus 6x is negative 5x plus 14 equals 4. Subtract 14 on both sides. I get negative 5x equal to negative 10. And then divide by negative 5. We'll get x equals 2. Once you have the value for your x, you can now either use the first or the second equation. Okay? Or you can also use this. Now remember, this equation came from my second equation. Okay? So since we are going to solve for y, I would rather use this one. Okay? I'll just use this one, which is from my second equation. If you want to use the first equation, it's going to work also. Okay? So I'll just use this equation. So I'll have y is equal to negative 3x plus 7. Just replace my x by 2. So we'll have negative 6 plus 7, which will give us a positive 1. Okay? So we already have the solution. My solution is x is equal to 2, y is equal to 1. Okay? So here we go. Now, if you decided to use the first equation, you'll be able to get the same y value here. Okay, so let's say, okay, let's try. If you're going to use the first equation, which is x plus 2y equals 4, and you replace, we are going to replace x by 2, we'll have here 2 plus 2y equals 4. Okay, subtract 2 on both sides, you'll get 2y equals 2, and then divide 2 both sides, you'll get also y equals 1, which is the same y value that we got here. Okay, after this, we have to verify our answer. So I have here 2 comma 1, I have one solution. So let's verify this one. So I'll use x plus 2y first equals 4. So x is equal to 2, y is equal to 1. I'll get here 2 plus 2 times 1 is 2. I'll get here 4 equals 4. So it worked for the first equation. Let's try to verify the second equation. I have 3x plus y equals 7. I will replace x by the x value, which is 2. Y is equal to 1. I have here 6 plus 1. 6 plus 1 is 7. So after we verify, we got a true statement for both equations. Therefore, we are confident that the answer for this system is 2 comma 1. All right, so the next example, example number 3, it will be the same system, but instead of us solving for y, we are going to solve for x. Okay, in solving for x, you have to make sure that when you solve for x, you have to avoid any denominator. Okay, so which equation do you think, okay, is the best equation wherein we can solve our x? The first one, okay? Because if you are going to solve for x in the second equation, you have to divide by 3. And when you divide by 3, you might end up getting a denominator, okay? So I will just solve x from my first equation. So if you solve x here, what's going to happen? X equals negative 2y plus 4. After getting the x value, what's our next step here? We replace the x value from the other equation. So the other equation is a second equation. I will have 3 times x plus y equals 7. So again, after getting the x value from the first equation, I will use this x value and plug it into my second equation. So I will now replace my x value in my second equation by negative 2y plus 4. So solve this new equation for y. Once we simplify this, you will get a value for your y. So let's distribute 3. I'll get negative 6y. 3 times 4 will give us 12 plus y equals 7. So let's combine negative 6y and y. It will be negative 5y plus 12 equals 7. Now we subtract 12 both sides. I'll get negative 5y equals 7 minus 12 is equal to negative 5. And then we divide both sides by negative 5. We will get y equals 1. So when you write your solution, you already have half of your solution. Okay, your y value is equal to 1. Now to get the x value, I can choose either the first equation, the second equation, or the equation that was derived from my first equation. Okay, so I will just use this one. X equals negative 2y plus 4. Negative 2y plus 4. Again, you have the option to choose the first equation, the second equation, or this equation that came from the first equation. I think it's simpler for us to use this equation that came from the first equation. So I will have here x equals negative 2y plus 4, but your y is equal to 1. So I will have here x equals negative 2 plus 4, and x equals 2. So I will have here 2 comma 1. And again, don't forget to verify your answer. If you compare this from the previous solution that we did, wherein we solved for y, we also got 2 comma 1. Okay? Here, when we solve for x, we got 2 comma 1 also. Okay, let's try to do number, go ahead and do number 6. So when you are solving for your variable, isolating an x or a y, the best procedure is for you to isolate a y that has, or isolate a variable that doesn't have any coefficient. So in this particular example, it's better for us to solve for y. Okay? If you solve for x, for example, in the first equation, you'll get a denominator of 3 when you divide 3 both sides. And you don't want to have a denominator. Same thing with the second equation. If you solve x for the second equation, you have to divide by 2, and you might end up getting a denominator. So in this case, it's better for us to solve y. Okay? And if you look here, y has no coefficients. So that's your hint. Solve a variable that doesn't have any coefficients. Okay? So in this case, we are going to solve y from the first equation. So what is y equal to here? Negative 3x plus 9, right? Now use this y value and plug into your second equation, or to your other equation. So I will have here now 2x minus y equals 1. So I will replace my y value from my second equation by the y value that I have from my first equation. So the y value from my first equation is negative 3x plus 9. Okay. Now you have a negative before the parentheses, so what we have to do here is to distribute your negative to both negative 3x and positive 9. So negative of negative 3x will give us positive 3x, and negative of positive 9 will give us a negative 9, equals 1. So what's 2x plus 3x? Okay, this is just 5x. Minus 9 equals 1. When you add 9 both sides, we'll get 5x is equal to 10. And finally, we divide both sides by 5, and we'll get x equals 2. Once you have your x equals 2, you can now use any of the equations. You can use the first equation, you can use the second equation, or you can use the equation that we derived from the first equation. So in this case, I'll just use y equals negative 3x plus 9. So I will have y equals negative 3x plus 9, but our x is equal to 2. Okay. What's negative 3 times 2? Negative 6. When you add 9 to negative 6, you're going to get a positive. So the solution that we have here, x equals 2, y equals. Okay. Now don't forget to verify your answer. Replace your x from the first equation by the 2 here. My y is 3. So this is 3 times 2 is 6 plus 3. Indeed, it is 9 equal to 9. Okay. Check the second equation. 2x minus y is 3. And now checking this equation, we get 4 minus 3 equals 1. 4 minus 3 is actually equal to 1. So here we go. since we verify both equations, the solution worked for both equations, then indeed our answer here will be 2.